Hello, and welcome to yet another stream here on the channel. So, during the last episode, I refactored a lot of the renderer API, and we actually got back to a point where we were mostly doing whatever we were doing before the refactor. So, yeah, we implemented this front-end stuff and then some backend calls. Yeah, which was basically the overall plan for the refactor. I can't remember. I don't think we cleaned up this stuff, but I still think we have linear buffers, right? Yeah, we do. Yeah, I think I would like to rename this eventually. Should be renamed. I'm not gonna bother right now. And we have all of this stuff here to clean up. Let's see, and we have our stuff here. We have something for instance draw calls. Yeah, so we still need to implement the debug calls. And I think on the front end here, the front end, we could do something like well, what does our debug renderer actually use for rendering our debug primitives? Let's look into that. So we have some polygons, blah blah blah. We have this line pipeline that we are not really using for anything right now. We also have this ABB thing that we should probably rename because we have a separate spheres shader. Let's see. We grab a transform. And as far as I remember, we have a kind of like, yeah, polygons. We have a box, line drawn. We also have a sphere. Yeah. And we have a separate primitive buffer for that. I'm guessing, yeah, this is fine. I would like to rename this though. And right now we're not gonna implement the line stuff. Um, Primitives. And let's see. Debug primitive pipeline. And let's hide the old stuff. We don't need to fiddle around with the buffers. We should create a pipeline for it. Debug primitive. Okay. Let's do one here where we debug primitives. We have our line. Oh, this is line list, right? Line list. No. D3D primitive topology. Is it a line list? Here we go. Okay. Next we have the initialization step. Let me actually clean up the compiled directory. And initialize. Oh, not. Oh, we need a root signature as well. Okay. Let's do. Uh, and this should be. Oh, the empty. Well, okay. Second is debug. Okay. mdevice.git. Oh, the root signature is the second one, and okay, and then we can just copy these things here. And then we get the pipeline and set the name. New debug primitive PSO. And then we want a structured buffer. Let's see, past data material. What did we actually use back then? Create, update, debug. Oh, that's the old one. Debug primitive instance data. Create debug buffers. Is it in here? Yeah, it is. On the upload heap. Okay. And we never create a descriptor for it, I guess. I guess you can just use a raw buffer that's not a texture, even though it's defined as an SRV. I guess. Okay. Structured buffer, initialize, not with the extra e, device.get. And let's see, kilobyte 64. Upload heap. There we go. And buffer size here. Let's see, in our old draw calls. Yeah, it doesn't really care about the offset. I think it's just an empty buffer. The indexing into it will be dynamic. Yeah, so it fits that we only have constant buffers set this way. Okay. It definitely doesn't like that. What about up here? No. Come on, IntelliSense. Old buddy. Oh, now it recognizes this one. Okay. Now that is a bit annoying. I don't know why. It's a bug. Okay. So we only need we need two parameters. We need cube instances and sphere instances. That's it. So somewhere around here, upload debug data. I mean, these parameters here will be hard-coded. So basically we need our debugging stuff to be submitted. Let's see. For the spheres, we do like that. And for so we do scale, translation, and color. Here. Yeah, we definitely need the scale. So we need scale, translation, and color, which are okay. So basically we can break it down into the mesh data is primitive type 32-bit int, and then maybe a color 3 floats. Let's see, float x64 bits. GPU floating point NVIDIA bit. Okay. HLSL. Uh, Okay. Um, uh, let's see. Oh, game dev is just so slow. Yeah, it crashed. Okay, anyway. What we want to do is kind of like submit our mesh data here for our debugging primitives. So that means that we have a primitive type, we have 3 floats as our colors, then we have our transform data, which is position and scale. What if we packed it all? So this would be times 3 floats. Then we would have 3 floats here. That would give us 10. We could almost reach 12, but we don't need the data. It's probably better just to pack it like this, then at least one of them can be packed and neatly fit into several cache. Several instances of this could be fit into a cache line. I think that's probably better than. It's not optimal. Okay, anyway, I'll split it like this. Might end up merging the two structures, but let's see. Struct debug mesh data. Let's do a UN32. Could we even pack it? I mean, let's see. No, it's still 9. Anyway, type and then a float. XM float. XM float 3. Color. Let's do a white space color. Let's see. Float 4. Yeah, we will change that. We won't care about the last part. Or we could transform it. I mean, basically, yeah, the transform itself is just fine. Yeah, okay. We already have a transform, which we will be using right there. So we have our transform data. Well, maybe we would want one debug transform. Yeah, this is what we do. This is the way. This is the way. Okay, so for debugging, debug vector. No mesh. Debug mesh. Ah, wait a minute. No, mesh data. Yeah, that's what our application actually submits. Mesh index, blah, blah, blah. Debug transform, debug transforms. Let's see. For debugging, let's do XM float 4x4, aligned, debug mesh matrices. XM float 4. Debug mesh colors. And let's do transient. Not debug mesh data, but debug transforms, clear. And debug area and debug area. Okay, and then we will simply, yeah, this. Hello, buddy. How are you doing? Debug mesh data. reference mesh data in the transients data store with the debug mesh data. Data. Oh, we don't need to do this actually. We don't need the mesh itself. Okay. Thank you very much. Thank you much. Thank you very much. Nice of you to tune in. So generally, our debugging API is doing something like boxes, spheres, debug boxes. Let's preface it with debug every time. Huh? What did I do for debugging? Oh. Oh, it's in on the draw call. Ah, yeah. Okay. First we do like this. Mesh data type. Let's do yeah, so we do like this. And next. Let's do frame, not draw, call data store, mesh colors, pushback, and placeback, or what? No. Yeah. XM float 4 here. Color X, Y, and Z, and then we do like that, and then debug transform inside the transient data store. And we compute the translation and scale matrices, and then we do like this. And instead of this, debug matrices. Okay. Okay. Let's see. Let me just check some stuff here. I don't know why it keeps on fluctuating a bit, but I don't know. Maybe it's just because I'm running a lot of different stuff. Anyway. Anyway. So our renderer here needs actually a method. I'm programming a top-down kind of like maybe crafting. Uh, let's see. Sorry, just a sec. Uh, okay, let me just so a space-based crafting slash simulation slash thingy kind of game. Right now I have implemented started a build system where I can create different things that I want to build. Right now we are not building anything because I haven't implemented that, but hello, how are you doing? I'm pretty good. I'm pretty good. Just doing some evening work here on this game. I'm programming a space-based simulation crafting game. Uh, Let me just show you in just a sec. So let's see, we need to place back this, and then thank you. Oh, this is debug transforms. Thank you very much. Um, so, uh, right now we have this guy here in space, and we can click a build menu and get a hologram here with the building. I've implemented the start of a builder system where we can, for instance, change the highlighted area around the build area. So as you can see, I just removed the outer part of the blue area. Yeah, so I'm constantly working on either the renderer or the actual game, because right now, yeah, we have we have lights, we have shadow mapping with a global light, we have textures and stuff like that. We have some cameras. We have a free-floating camera. I wonder why it makes these artifacts here. Maybe it is related to VSync, or maybe it only happens when we're directly hit on, it seems. Thank you. And yeah, we have a skybox, so if we look around, we have yeah, a Milky Way. There's a link in the description. It's an actual picture, I think, of the Milky Way, so our galaxy. Okay. Uh, this game here, I don't know. When did I start? A month ago or something? Let me just check. I first built a, let's see. Yeah, I used my old engine parts. It's actually only been 2 weeks. So, I did another project here on the channel. Let me show you. There we go. I did this project before. I even get the lines here. Maybe it's an interaction with the OBS thing. Anyway, this is a first-person 3D kind of thing with a physics engine. So you can see I can move this model, and it has some physics interaction. Oh, well, that's a bug. I never seen that before. But yeah, so I had some engine parts, but basically I've been refactoring a lot of it. So most things are implemented in a slightly different way in this engine. You know, you get more clever about how to do things and get more experience, so things kind of evolve. So yeah, we added the debug interface. Let's see. Let's try using it. Not that we are gonna see anything rendered to screen because yeah, I don't know how old you are, but I actually started out by being a web developer back when I was a teenager. So okay, so let's see. Core grenderer, draw debug primitive, and we need some mesh data. Debug core debug. Well, then just do some what do you call it? Game programming on this side. Keep on making websites. That's probably a good way to make money anyway. Let's see, debug prim. Let's create a green one. Oh, did I actually? No, I didn't. Did I? Did I implement the? Yeah, I did. Okay. But did I implement it correctly? XYZ, yeah, okay. Debug prim, and then the transform, core debug transform, debug transform. Let's just do debug transform. Debug transform plus Y. You too, man. Thanks for tuning in. Take care. Okay, so we have created a simple debug call, but as I've mentioned, nothing will be happening. So let's create a backend call. Upload, debug, pass data. Oh no. Update, debug, frame, resources. Let's do a const std vector. Debug transforms. Or what did we end up actually? Okay. Just matrices and colors. Matrices. colors. Okay. And let's do an implementation. Let's do pipelines, DX12 pipeline type, debug primitives. Let's see, structured buffer. Let's do a byte pointer, address. Let's see, get memory. Cast as a byte pointer. Yeah, maybe we actually don't need this. Or do we? Yeah, we do. Or maybe we don't. Maybe we don't. Yeah, whatever. Yeah, we do. Maybe we don't. Maybe we do. Maybe we don't. Maybe we do. A little I in here. Not the sailor I, but the I. As in, I do it. Anyway, me being silly aside, we could do something like, well, let's create some object data, or let's see, what do we actually pass along into our shaders? We do instance data. We have a corresponding thing that we usually use. Debug primitive data. And this is inside our, this can be disabled, right? Why would we have problems doing that? Did I mess something up here? Huh? Oh, maybe I'm just not huh? Okay. Yeah. I think we don't need this. We don't need this. We still want this information here. Let's see. Let's remove this for now. We don't need this anymore. Debug object. Okay. Why are you whining about that? You shouldn't be whining. Maybe you're just whining because you want attention. Okay, and let's comment out this. And inside this. Oh, yeah, okay. We wanted to change this anyway. So Okay, this should be fine then. Okay, and in here, we don't need this anymore. We actually don't need this anymore either. I also want to disable this for now. Let's just leave it. This one is definitely going somewhere very far away. This will also get moved. This is fine. This is fine. Let's just move this away down here, maybe. We have our pipeline stuff, which is still fine. And we're looking good here. Yeah, do we have any leftover calls or methods? Probably. Oh yeah, of course, we don't need to do this. There we go. And we're back. Okay. So let's do our implementation here. Debug object data. The transform is equal to our matrices I, and the color is equal to our colors I. And I mean, I guess we could collapse this. Yeah, we could collapse it. Let's just do a comment here so we can see the memory operation memcopy from, or rather to, our pipelines. Let's just take our address here, plus I times the size of, oh, let's just pre-compute that. Const unsigned int size color size of const unsigned int size matrix size of and the first part, oh, now we need our debug data again. Okay, the first part is the transform. Let's actually do an align type here. Yeah, so the first part is the matrix. So let's actually kind of like write that first so we can remember. Plus maybe just const unsigned in total size color plus size matrix times total. Maybe even size t here. Okay, so we offset into our destination buffer for each element. And we write our matrices I. And we write the size of the matrix. The one that Neo is caught in. I'm sorry. I'm making stupid jokes all the time. Anyway, and secondly, we want to only offset by our matrix here. And write our color information. And there we go. And let's do that. So we want this call inside our, well, not yet, but inside our DX12 renderer, debug, we'll update debug frame resources. Let's do draw call data store debug mesh colors, draw call data store debug matrices. There we go. Everything should compile just fine. Oh wow. Okay, we definitely have some error. What happened? Okay, we're overwriting something that we don't want to overwrite. Now that looked rather funny. Funny bug. Huh. Did we? Huh? How? Did we? Not. Yeah? New debug primitive. PSO. No, not PSO. Structure buffer. Maybe the way we order our draw calls? Backend calls here? Yeah, maybe. Well, I mean. Okay. Debug. still. So we're overriding some memory location that we definitely don't want to be overriding. And then, okay, what's going on? New debug primitive structured buffer. Let's do make some flow, or rather float forward 4, float 4. So this looks like our data. Huh. Coherent map. So what does that actually imply? Now that's a weird bug, isn't it? Oh, maybe is it inside our pipeline stuff? No. No. This buffer should be different. Let's see, if I don't do this call, or rather, if I just disable this mem copy here, will we then end up in the same situation? Nothing is happening now. What if I mem copy then? And then we have a problem. Do I pass in? No. The debug matrices are fine. So what if I do the mem copy of the color? It's like we're almost messing up the pass data itself. Like the camera is all messed up. For some reason. I don't know why. How come? So let's just try doing this and looking into the past data. Yeah, some memory. Maybe we're accidentally writing into another buffer. Let's see our past data buffer. Usually our past data I'm a bit confused. Let's see. The layouts. Okay, so we have a XM matrix float 4x4, then a float 3, then a float, and then some directional light stuff. But yeah, I mean, this looks like garbage values. But I'm not sure, is it? I'm pretty sure they are garbage values. And then light directional, then float 4, float 4. And then float 4x4. Huh. Okay. Let's just not do this then. Just upload one. We're kind of like losing frame. Oh, wait a minute. I of course need to reset some stuff, right? Yeah, I do. I also need to debug boxes. Is that what we... No. Debug. Oh. Colors. Clear. Okay. Oh yeah, so if that kept on growing, we would end up growing the underlying buffer, and then it would eventually spill into the past data, uh, which is why we had that problem. So this should work fine now. The bug was just a memory leak. Yeah, everything is stable now. Yeah, okay, fine. Yeah. Okay, so we update our debug stuff, and we can then again move it down here. It doesn't really matter. Upload debug data. Okay. Yeah. So next we want to actually render our debug primitives. Let's see. Debug render pass. No, let's just do unsigned int. Actually as a const. Boxes, const unsigned int. Spheres. And we will do a simple implementation here. Simple implementation. Since debugging is not part of the final project and only for kind of like the editor and stuff like that. Yeah, we won't. Yeah, we won't be very meticulous in terms of implementing something very dynamic and sophisticated. Okay, we need to link the what do you call it? Whenever we create our debug buffers here, we want a vertex buffer view to be our equal to this dot get view. And we need to cast it. Index buffer view. And we set our index buffer view here. Okay, so now we can use it in our pipeline. Vertex buffer view. Index buffer view. And let's see. We do like this structured buffer get GPU virtual address. And let's do boxes. Or rather, this is hard coded, so I think it's 24, right? And this is just boxes. And this is boxes. And I can't remember the sphere indices. Let's see. Can I find it somewhere? Maybe I can. Spheres. Let's do maybe a const expression unsigned int box indices const expression sphere indices and then const expression unsigned int box vertices, and this is going to be 8, and I think this is 24. So box indices vertices, and then we have sphere indices, and we will know whenever we what do you call it, restart the engine. So let's see, DX12 renderer, and we will simply debug boxes, debug spheres, and there we go. Okay, we're not drawing anything right now. Anyway, let's see. Sphere indices 420. 420. So let's see what's wrong in terms of our draw call. Do we actually create a box somewhere, or yeah, let me just debug this in render doc. Alright, we have our new debug structured buffer here. Float 4x4, float 4. We should have a, oh, it has one on the X, but our color is black though. So yeah, maybe the upload algorithm is not great. Oh. There we go. No. Plus. There we go. This is the way. This is the way. I think. I was maybe a bit too certain here. No. Uh, float 4x4, float 4. Okay, now we do actually upload our information correctly. So that's not the problem. Let's see our color pass here. What do we end up? Mesh viewer. We should draw a cube. No instances. Verdicts. I'm pretty sure this is correct. It also actually knows. Am I not binding the correct what? I'd say this is correct, but we're not seeing anything. I'm inside this just to make sure that we actually. Did I set up these settings wrong? So the structured buffer is bound. Our thing up here should work. It should work. Debug boxes, debug spheres. I mean, the draw call itself is correct. So what's wrong? Oh, yeah. I think I know what. We don't have any pass state actually bound. So it doesn't know how to actually access the camera transform, I think. Since we swapped the root signature. No, that's not it. That's not it. Did we just see a bug? No. And what am I? Let's just do a test transform here. Scale 5 maybe? And let's look in our transform computation. Scale XY. So that's not it. The color is set. We saw our data was correct. Okay, so nothing's, oops, nothing's happening. Huh. If I compare to another pass, and inside our root signature, let's see. The first one is that, then the shader. That should be correct. Huh. Let's try disabling this just for now. And I want created box maybe 824. Okay. So that's not it. And we have the pass data. Okay, let's see. Is it our pipeline state object that is not created correctly, or... Oh, what was that? Capture. Oh well. Debug, PSO. It is bound to be correct. Maybe we want to do it before the ImGUI stuff. Huh. Why would I use it? Okay. Yeah, so the ImGUI stuff invalidates probably some stuff. Yeah, okay, now I know why. It's because the ImGUI stuff changes the descriptor heap. And probably also the viewport. So yeah. Okay. So that was the problem. Then we should do some stuff here. Let's do and let's copy this inside. This is the scale. UI. Okay. Then we want and this should be removed. And we should be back rendering, yeah. This always flash debug information is useless. Let's see. Right now we just do it. Let's see. Clean up this. And we can easily do some hard-coded debugging stuff, like the lights inside the renderer itself. We don't need to do it outside of the renderer anymore, which is great. So the API is simply doing calls like this. Yeah. Okay. So for the spheres, we need to do something. The problem is now that the application should probably know the color of the mesh itself. We could do something like let the application create a debug thing. Yeah, we could create an array that holds the. No, we don't need this anymore. So let's clean up that. Yeah, this is more clean also on the application side of things. Let's see, we split off the rendering. Yeah, we could just do something like we could do something like application transient data. Debug color array. Transient data. And then let our, yeah, we don't need to set this anymore. We can kind of like when we created game, player creation. Sphere colliders. Oh. Transient data. Let's see, and place back. Let's do a green one. Yeah, this is probably not the way it's supposed to be anyway. Data, color data rather. Okay, and then yeah, we simply do this as we did before. So we will do a quick reset each frame. Let's just do const xm float 3 in transient data. Isn't this correct, or am I? Oh, I need to do it capital. Color. Huh? XM float? Did I spell it wrong, or? Anyway, color equals, well, yeah, not constant. It doesn't make any sense. Okay, and then we can always do like this. Huh? Oh, yeah. Yeah. Right now it's hard coded to the player. And then I yeah, we'll do like that. First reset color. Then highlight player if colliding. Player collider. And let's do a thing here. like this. For now, we won't be doing that, and we will have a type of 1 here. The color will be like this. Transform. And this is the scale, this is the position. Right? No, that's the color. This is the position. This is, there we go, and then the scale, right? But what on earth was that value? Yeah, anyway. And this is mostly going to be the same thing. Plus I. Okay, are we done? I think so. Maybe. Okay, I obviously didn't end up actually. Huh. So we have a problem submitting the. Okay. Oh yeah, okay, I know why. It's because we disabled the sphere rendering, of course. And we're back. Okay. Obviously, we need to fix the coloring here. 1 plus I. There we go. But no reset. Huh? Well, this should be an overwrite. But, I mean, are we actually kind of like having a small memory leak here? Are we? No. Then this should be resetting it, and this should be coloring it, but only if this. But okay, our collisions inside our. Is it simulation? I think. Yeah. Our collisions are not reset or what? Each frame. I think they should be. Are we actually overflowing here? I guess it's because only we're only adding ints. No, that's not it. Maybe I even reset it in the application somewhere else. I don't know. Anyway, that's not it. Okay, let's see. Does this even work? Just as a baseline, no, it doesn't. So it's set to whatever color. Huh? I mean, this is pretty weird. Shouldn't this just overwrite the color? Um, I mean, this should really reset it. This even works, but maybe it's the follow-up. Let me see. Nah, can't be, right? Maybe it's the variables, or I don't know. I mean, this is not to be misunderstood. So, yeah, okay. So this for loop here, probably. I mean, it should be scoped. Huh. I don't know why. Maybe you're not supposed to do assignments to. Maybe it's because we're having some kind of like const on the underlying iterator stuff. Anyway, we found the bug. And we're back. So we have our collision algorithm up and running, and we have our debug stuff rendering for that. Okay, and then as I've mentioned, the front end will now have directly access to whatever primitives it wants to render for our scene. So for our main lights, let's just create a hard-coded um, debugging sphere for the lights. Debug sphere. So we have our XM matrix here. Main lights dot position dot x, right? And our y position and our z position. And our scale is just going to be as is. I'm unsure whether. Oh my god, I opened the file which I shouldn't open. I mean, now IntelliSense is so freaking mad. Okay, it actually assigns an identity matrix, so I don't need to do that. Okay, let's save that and then reopen this. Thank you, Microsoft, for creating so many wonderful bugs in this program. Let's cut them some slack. It's definitely, what do you call it? A pretty complicated piece of software. There we go. Yeah, I think I'm gonna reorder this. So, and then we do a debug sphere. And let's see. Okay. We aren't getting our lights rendered for some reason. Okay. So back in the day, we simply hard-coded it into the thing here and create drawable mesh, blah blah blah. That's some old debug data. These are old versions of whatever we did back in the day. Let's see, ordered. Yeah. Light position. Light position XY. Let's disable these calls. And see. We have our spheres. Do we need to? Let's just try scaling it, even though it shouldn't matter. 3, no, rather 2. Oh, I know why now. I immediately saw the problem. We don't upload a matrix. We got no Neo. Therefore, it won't work. There we go. And we have everything up and running again. Let's see. Colliders. There we go. So our backend, or rather front end, knows that our light should have a sphere of sorts. Right now our show debug stuff here should maybe just toggle the submission of all of this stuff. Oh, show debug should be turned on and off. Huh? Oh, it does work. It's because this one is hard-coded, so it will always render. And I think that's fine, at least for lights. We don't mind the lights being rendered all times. So we have a sense of where our sun is in the scene, even though I think so the direction itself should probably rotate or affect the yeah. Yeah, maybe. Yeah, we should play around with this because when we adjust the actual position of the lights in our scene, the debug thing doesn't update. I mean, if I let's see. So I kind of like move it down the horizon, and now it's under the scene. If we take our camera down here, everything is lit on the underlying side. So I would like this debug primitive here to kind of like move up and down according to the lights, but uh, that would also make it kind of like rotate on the other axis. Yeah. So that's a bit more complicated. Basically, we would want basically we want what we're doing in terms of handling the shadow map. So basically this information here, we would compute a view matrix for the lights, which looks at our defined scene center, and then basically this is what we need. And if we just multiply the original position by this matrix, we would get our actual position. Yeah. Okay. I guess we could do it. I guess we could do it. Just as a proof of concept, even though. Load throat 3. Don't we frame data? Oh yeah, so it's stored in the frame data. There we go. We will compute this twice, or maybe just, maybe we don't want the, yeah. Oh, I did it again. I did it again. I did it again. I messed up intelligence. Why can't I peek at the DirectX math library without getting into trouble? XM matrix, translation from vector. There it is. Okay. Does this, oh, wait a minute. This is out of scope then. Let's just put it back into scope, as they say. Yeah, we kind of like doing, whoops, some computations twice, but yeah, it's not very complicated math, so. Okay, so right now we don't have a, oh, it's up there, okay. There we go. There we go. Now that looks pretty neat, right? And we can, and it's looking at the center right now, so it's rotating around the center. Yeah, that makes more sense. Yeah, and the vector math is not very complicated. We could actually just pass along the position in our frame data instead. Yeah, we don't need to pass this along. We could do, oh, do we actually use the scene center as well inside the shadow map stuff? Yeah, we actually use it for the other parameters as well. Not the scene center, or rather the, yeah, the shadow map radius we do, but we, oh, we do scene center. Okay, whatever. We're gonna use all of it. We could then pass along the DirectX XM vector light main light position. And simply compute that. And frame data. Let's do XM store float 4. No. Equals light position. And then we don't need to do this. Let's do frame data. light position. There we go. So we simply skip that computation. So let's find our main light here. If we change the color and the position, you see the sun is moving around, and the shadow is, of course, casting. Yeah, this is related to the viewport of what do you call it? And it's rotating around the center of the scene, which is right now the origin. So we can actually see our directional light being moved around the scene. Great stuff, great stuff. Great stuff. Okay, so that's it for the renderer refactor. I wanted to do some dynamic texture creation and stuff like that, but I don't think I'll make it today. It's getting late, at least in my country, so yeah, I should probably start considering ending the stream for today. But yeah, basically the render refactor is done. I changed the whole front and back end coupling, and also created a more elegant way to actually draw things from our application. So our application doesn't need to know about anything almost when it wants to draw something, and we don't have several layers of copying the exact same data all over the place. So whenever our front end wants to draw something, it needs to register a mesh, a material, a texture, and some flags for the actual mesh, whether it's supposed to be visible, cast a shadow, be transparent, whatever. And whenever we know that, we can also supply the basic transform data, the position, the scale, and even the orientation if we decide to specify that. For instance, we could, well, I don't know. I'm not gonna bother. Anyway, you can see down here we pass along a quaternion which controls the player orientation, and yeah, we can submit to different pipelines by simply specifying the draw flags. So yeah, that's pretty neat, and the actual function call on the front end is just draw mesh, and it will know what to do. And basically the thing is that you, for each frame, compile a list of transient data that you want to draw, and then during your actual draw call, you kind of like compute which draw calls are going to which pipeline by interpreting the flags, and then you compute the transforms and stuff like that, and then you upload it, and then you do your render passes. So it's pretty organized and pretty clear cut what we do. And yeah, you could simply swap the renderer backend into any other application, and the API calls would be fairly straightforward. You have draw mesh whenever you want to register a mesh to draw, and then you have the draw call, and then some draw parameters, which are mostly the camera information, at least for now. And then we have a debug pipeline that does kind of the same. Yeah, so that's pretty neat. I don't need this anymore. Next, I want to do a bit of cleanup on the rendering API as well, since I want to be messing around with dynamic textures. I want to experiment with a compute shader potentially that creates a dynamic texture, potentially for each frame, or maybe each 10th frame or whatever. But basically that allows us to input some data and then do manipulations on that data and create a texture on the fly that we can use for our game world. But in order to do that, I'll need to improve the coupling between ImGUI, yeah, the icon specific. We have some kind of group rendering already. Flags we do have. So this is actually done. Grouped rendering is kind of like what we've done, but we want to, let me just delete this and then do a new sticky. We want to be able to do icon loading, specifically for ImGUI. We want to be able to bind textures by index in the renderer front end, or rather, let me rephrase this. Front end, renderer front end should have custom textures. Custom / procedural textures available by index. And then I want ImGUI needs to be able to reference these special textures. Yeah, I would like to do some work on it now, but I don't think I can make it before I have to end the stream. But basically, I would want a panel inside the renderer. Let's see. Okay, let's create. Yeah, we have. Let's do renderer UI panels. Let's see. Settings panel. Yeah, let's do that. Panels. And then inside our renderer here, panel, settings panel. There we go. Let's create one more for image texture viewer. False, maybe true. Yeah, if panels texture viewer texture viewer. Let's do this. ImGUI end. And let's just do ImGUI image here. And this is the one that we created. Let's do 64 times 64. And this is fine. And that's not the one. This is the one I created. It should be fine, right? Oh, wait a minute. I forgot that the index 0 is the same as a potential null pointer, and then it doesn't know the overload. Anyway, so now we can create a panel here where we can view a specific texture that is already bound to ImGUI. So if I'm just gonna speed run this a bit. Let's see. Let's do resource creation. Let's do just something like maybe custom textures. Let's see. Void create custom texture. Okay, and then on our backend, whoops. On our backend, we would want something like, I think this is gone. This is also gone. Let's see. Let's create an unsigned int. Create bind ImGUI texture. Something like that. Okay. We do have a ImGUI struct, right? Don't we? Don't we? Don't we? Don't we? Yeah, we do. Let's see. Unsigned int number of bound textures. Finally, some use for that structure. Okay, so right now we kind of like do it right here. Let's just actually use this. Yeah. Yeah, so this kind of like keeps our binding to ImGUI. Yeah. Yeah, so this basically binds whatever texture we want. Let's see. Here we want to do this and then return this. Maybe this is better. Yeah, that will return the proper index, I think. So let's just do something like, well, let's do a texture array. Let's do a DX12 cost texture array again here. Custom texture array. Pushback, or rather just in placeback. Let's see. Dot back. We get the yeah, potentially we would create some resource here. Yeah, but I think I gotta go. So, anyway, this will end up being a way to view our custom shader slash procedurally generated texture. Maybe we want to be able to create it and update it first, but then again, we would like to be able to view it. So yeah, that should probably go hand in hand. Anyway, let's see, if we increase this to 4, you should see the texture changing in the panel. Yeah. Anyway, oh, whoops. Yeah. Yeah, but anyway, we'll fix this probably during the next time I stream, and then I'll start messing around with the procedurally generated textures. Yeah. So that's it for today. Thanks to everyone who dropped by and interacted, and yeah, thanks to everyone who supports the channel. Um, yeah, we will continue the work on the engine here very soon. And of course, I'll soon start to build out the building system here. Yeah. And maybe do some game logic or some gameplay. Yeah, I really want to do a procedural texture that kind of like colors the most of the ground, and then my idea is to kind of like let the texture interact with the game state so that we get a texture that kind of like changes, evolves, maybe even grows a bit, depending on how expensive this will turn out. But yeah, first off, we will start out by doing some noise functions and doing do something that is probably tileable, and then depending on the scale itself, we'll mess around with how it'll behave and end up looking. But yeah, I think that will be very interesting. Not at least from a technical perspective. So yeah, but that's it for today. Thanks for to everyone who supported the channel. If you want to support the channel, please consider comment, liking, or subscribing. Also, there are ways to support the work in the description down below. Also, we're coming close to 500 subscribers, and I've actually considered maybe doing a short tutorial video here on the channel as a celebration. So if you have any wishes in terms of rendering implementations that you would like to see, feel free to interact and leave a comment. Yeah, that should be pretty cool. Maybe we could expand on the toon shader that I created in the latest tutorial series. But yeah, that's it from me today. Please take care, everyone, and keep on trucking. Bye bye.